If C is a constant vector, prove that del dot C dot R vector into R power n R vector is equal to n plus 4 C dot R vector into R power n. So here this R power n, no, this is a scalar one and this is a vector one. Similarly here this is R vector and this R power n is a scalar. Now you have to prove that these two terms are equal. So just you consider the left hand side. So I have written this left hand side. Then del dot some value. Okay, del dot phi அப்படின்னா dou phi by dou x plus dou phi by dou y. That value you have to return. So the summation I have written. Summation dou by dou x of C dot R. Okay, these dot product should be represent for vectors. So C dot R vector R power n, and here we are having R vector. So this R vector is representing xi vector plus yj vector plus zj vector, zk vector. Okay, dot product find out பண்றப்ப you will have only x. Okay, so that I have put it here x value. So summation dou by dou x of C dot R power n into x. Okay, this is the just a notation of the del dot this one. Okay, now next term is here dou by dou x of this term. So this term is involving as a three terms. C dot R, this is vector R power n, and also x also we are having. Three terms are in both are involving in x, y, z. So partially differentiated with respect to x now we need to use the multiplication rule here. So first I have keep the C dot R and R power n as itself. The another term is x here. So when you are partially differentiating x with respect to again x now, you will have 1. So the first term is C dot R R power n plus the second term is I keep this C dot R and x as itself. R power n I have to differentiate partially with respect to x. So n R power n minus 1 dou R by dou x. Okay, this R is a scalar one. Okay, this R is a scalar value. Now next last term is I am going to keep this R power n x as itself. Next I am going to differentiate this C dot R. So here R is a vector value function. Okay, so C is a constant one. Okay, constant vector. C1 I vector plus C2 j vector plus C3 k vector, that is C. So this value dou R by dou x we are getting. So C dot dou R by dou x. So the second step just I have differentiate partially with respect to x this term. Now the next term, so first term as itself same term. Now the second term this dou R by dou x value is x divided by R. This already we have proved because dou R by dou x, R is a scalar function. Okay, so usually R vector அப்படின்றது is a xi vector plus yj vector plus zk vector, right? And this R is a scalar valued function. That R value R squared is equal to x squared plus y squared plus z squared. So அதிலிருந்து you have to find out that dou R by dou x, that value is x by R. This already we have proved on the previous problems. Okay, so this dou R by dou x value is equal to x by R, where R is a scalar one. Similarly dou R by dou y is equal to y by R, and dou R by dou z is equal to z by R. Okay, when R is a scalar one. So for this value dou R by dou x also I am going to substitute this value x by R. So when you substitute x by R now, already here we are having 1x. So x substitute பண்ணோம்னா that becomes x squared, and divided by R, already this term we are having R power n minus 1. So r power n minus 1 divided by r, now you get r power n minus 2. Okay, plus last term is x r power n c dot this r vector. So this is here is r vector. Okay, dou r vector by dou x. Dou r vector by dou x is I vector, because r vector is xi vector plus yj vector plus zk vector. So dou r vector divided by dou x, that is equal to this one I vector. So just I have substituted here as c dot I. Okay, so this is the term. The next term I have give that explanation. Now you come to the next step. So next step I am expanding that summation. Okay, the previous step just we have put it that summation, no, summation of these terms, right? So I am going to expand this summation. The first term is c dot r power n. Now this term will be appear for 3 times. Okay, the first here you are come across this I vector, no. Similarly next term la c dot j vector, that will appear, and the term is here y r power n. Similarly here n y squared c dot r power n minus 2, another term. X y z, that term will be repeated next terms. Okay, so here this term c dot r power n is only involving these terms. So definitely in next because this is summation only we are putting. Okay, so next term c dot r power n, that term will appear. One more term we have to expand, that term also having c dot r power n. So totally 3 times c dot r power n, that will appear. So I have put that value here. Okay, 3 r power n c dot r. Now the next term is this one, n x squared c dot r power n minus 2. Okay, this is one term. When you are expanding the summation, what will be that another term, n y squared c dot r, n y squared c dot r power n minus 2. Another term is n z squared c dot r power n minus 2. These two terms are extra terms will appear. So in all the terms we are having n c dot r power n minus 2. The variable changed term is this one, x squared, another one is y squared, another term is z squared. So you can take this n c dot r power n minus 2 common outside. So what you will get it, this term n r power n minus 2. Okay, n r power n minus 2 c dot r. If you take outside now, the remaining term is x squared plus y squared plus z squared. Okay, that is the second term. Now in the last term also we have to do the expansion. So this is the last term, x r power n c dot I. அப்போ நெக்ஸ்ட் டேர்ம் என்ன வரும், சம்மேஷன் எக்ஸ்பேண்ட் பண்ணுறப்போ y r power n c dot j. Another term is z r power n c dot k. This type of terms will be appeared. So in all the terms this r power n is common. Okay, so you can take that term outside. So you'll get this one, r power n. Okay, r power n into x c dot I plus y c dot j plus z c dot k. Okay, this will be appeared. Right, now the next term is just simplify that previous step, simplification of the previous step. First term அப்படியே தான் இருக்கும். Okay, we just keep that term as itself, 3r power n c dot r. Plus the second term is now this x squared plus y squared plus z squared term we are having, no, that is nothing but r squared term. Okay, that is equal to r because r is xi vector plus yj vector plus zk vector. So r squared is x squared plus y squared plus z squared. So that term, okay, n r power n minus 2 c dot r, instead of this term I am replacing r squared. Okay, now we come to that this term x into c dot I. Okay, r power n x into c dot I, அடுத்த term plus y into c dot j plus z into c dot k. Okay, just you concentrate on this one here. C is nothing but c1 plus I vector plus c2 plus j vector plus c3 plus k vector. C dot I is c1. Okay, c dot I. Okay, so that is c1. C dot j is c2, c dot k is c3. So here the term is involved as x into c dot I. So x into c dot I, just I am considering this term, x into c dot I plus y into c dot j plus z into c dot k. C dot I is c1. So c1 x plus c2y plus c3 z. That is nothing but c dot r. C dot r, c vector is this one, r vector is xi plus yj plus zk. When you are finding the dot product now, you will get this one, c1x plus c2y plus c3z. So this whole term can be represented as c dot r here. So the last term, okay, the whole this term, no, the bracket, the terms inside the bracket, these terms can be replaced with this c dot r. Okay, c dot r per n c dot r. Now in the last step is first term, we are having c dot r per n. Now we come to the second term, c dot r power n minus 2 into r squared. So when you are multiplying these two terms, what you will get, r per n. So n r per n c dot r. Okay, so c dot r, next term also c dot r power n. Three terms having c dot r power n. So c dot r power n, if you take common, okay, the first term the remaining element is 3, and in the second term the remaining element is n, and the last term the common value to know 1 is there. So 3 plus n plus 1. So finally we are getting that 4 plus n r power n into c dot r. So that is the result we need to prove, that is we are having in the right hand side of the given one. So we have taken the left hand side, now we are arriving the right hand side. So we got that result. So we proved the required one.